Okay, so today we need to start the equations of motion. So there are mainly four equations that we will discuss. Okay, so as a space rocket rises from the ground, its velocity steadily increases. It's accelerating. Eventually, it will reach a speed of several kilometers per second. Any astronauts aboard find themselves pushed back into their seats while the rocket is accelerating. The engineers who plan the mission must be able to calculate how fast the rocket will be traveling and where it will be at any point in its journey. They have sophisticated computers to do this, using more elaborate versions of the four equations of motion. There is a set of equations that allows us to calculate the quantities involved when an object is moving with a constant acceleration. Okay, so starting with the topic, write down the topic, the equations of motion. Okay, and then write down this point. Equations of motion can be applied to an object which is moving with a constant acceleration, Highlight the term constant acceleration. Okay, next line. When an object is moving with a constant acceleration, we say that the object is in a rectilinear motion. We say that the object is in a rectilinear motion.
Sir, could you spell that?
Yeah, sure. Rectilinear. Rectilinear motion. Within brackets, you can write straight line motion. So you can call it as rectilinear or straight line motion. When an object travels with a constant acceleration, we say that the object is in a rectilinear motion or straight line motion. Now, when we say straight line motion, the students will misunderstand. It means the object is moving in a straight line. Object is moving in a straight line is not a rectilinear motion. Because even the object is moving in a straight line, the acceleration can be varied, right? So first it can accelerate. Now let's say there's a straight road. The car is moving with some acceleration, like 2 meters per second square, and then hitting the brake, and then stop for a while, and then again accelerating with 2 meters per second square, and again accelerating with 3.5 meters per second square. So this acceleration is changing throughout the motion here, right? So then we can't say the object is in a rectilinear motion. We can't say the object is in a straight line motion if its acceleration is changing. Is that clear?
Yeah.
So object is in a straight line motion only if its acceleration is constant.
Okay.
Right?
Okay.
Okay. Let's write down that also. An object moving in a straight line separately, right? An object moving in a straight line
Okay.
doesn't mean
Okay.
the object is in straight line motion.
Okay.
Okay, an object moving in a straight line doesn't mean the object is in a straight line motion because even if the object moves in a straight road, because even if the object moves in a straight road, if its acceleration changes,
Hold on.
if its value of the acceleration changes,
Okay.
then it cannot be a straight line motion.
Okay.
So write separately, you can put a star and write. Thus, the object will be in a straight line motion only if its acceleration is constant.
Hold on. That's the object.
Object will be in straight line motion
Okay.
only if its acceleration is constant.
Okay.
Okay. So did you understand?
Yeah.
Okay. Okay, then let's write down the quantities involved in equation of motions. So write down subtopic quantities involved in equations of motion. Quantities involved in equations of motion. Okay. First S, which is the displacement.
Hold on.
S for the displacement.
Okay.
U, initial velocity. Simple it is actually. Initial velocity. V, final velocity. A, acceleration. And finally, time. Time taken.
Okay.
Now, for example, let's say we have a car, it start to accelerate from rest, let's say, or start to accelerate from 2 meters per second squared. So 2 meters per second squared is the initial velocity. And at that moment, we start the stopwatch. So time starts running. And then after 10 seconds, so the velocity is 10 meters per second. So the final velocity is 10 meters per second, right? So then S is the displacement traveled by that car within that given time. Is that clear?
Yeah.
Okay. Okay, so here, and this is very important. So we will see the four equations of motion, right? But here it says, take care using the equation of motion, they can only be used for motion in straight line. So we said motion in straight line means object which are moving at constant acceleration, right? In straight line motion, we wrote, right?
Yeah.
Object is in a straight line motion if its acceleration is constant, right? So now we can use the equation of motion if the motion is in a straight line, or in other words, the object has a constant acceleration. Okay, so first, before writing that, we will write down the four equations of motion. After that, we will write down that fact. Okay. So let's start with the derivation for all of this. Okay. Okay, so I'm going to derive all four equations of motion. Okay. Okay, let's consider an object. Initial velocity is u. That means at the time t equals 0. So at this moment we hit the stopwatch. Stopwatch starts running from 0, right? And let's consider the time taken is simple t, spent t time, and the velocity is v. And the displacement within this time interval is considered as s. That is the displacement. So this is the displacement, and then we consider the acceleration as a, simple a. Simple a is the acceleration. Okay, right. So now we are going to derive all four equations of motion, starting from the acceleration. So we can write acceleration of the particle. We know acceleration is equals to change in velocity over time taken. Change in velocity over time. For acceleration, we usually take, now acceleration is A, right? So A equals to change in velocity. So the change in velocity is final velocity minus initial velocity. So final velocity is V minus initial velocity is U over the time taken is T minus 0. So then we can write that is V minus U divided by T. Right? So A equals V minus U divided by T. Now I can take this T and multiply to the other side. Therefore, I get AT equals to V minus U. And then I take this minus U to the other side. It becomes plus U. So therefore, U plus AT equals V. So then we get V equals U plus AT. So that's the first equation.
Can I copy that down first before you move on to the next?
Oh yeah, sure. Once you're done, let me know.
Okay. Okay. Yeah. Hello.
Yeah.
Okay.
Okay. Now the next one. When an object travels with a constant acceleration, its displacement we can find by considering the average velocity multiplied by time. So here, right, when an object travels with constant acceleration, or we can say when an object in a straight line motion. Okay, because when an object in a constant acceleration motion, then it is a straight line motion. So we can say when an object in a straight line motion, its displacement is given by displacement is equals to average velocity into time. So displacement, we take the letter S, right? S for displacement. So average velocity, we can see within this time t, the velocity is changed from u to v, right? So within this time t, the average value will be u plus v. Since two values, we have to divide by 2. That's the average. Okay. U plus v divided by 2. And this one should multiply with the time. So time simple t. Therefore,
So
I
why
can
did you
write,
become? Why does it
Sorry?
become 2 again? Why does it become 2 again?
Because the average, no? Now suppose if you
Right.
have
Well,
2
2
and 4, two numbers, if you want to find the average, you have to divide by 2. Okay, so then here the average is 3. And let's say you have 3 numbers, 1, 2, and 3. If you want to find the average of these 3 numbers, 1 plus 2 plus 3, divide by, so here we have to divide by which number?
3.
3, because there are 3 values, we have to divide by 3. So you get
Okay,
here 2. Okay.
because there's 2 velocities, right? You divide by 2.
Yeah, so here we have taken 2 values, u and v,
Okay.
so therefore we have to divide by 2. Is that clear?
Yeah.
Okay. So therefore, I can write the equation S equals u plus v divided by 2 into time. So this is the second equation. You can write down this now.
Okay. Yeah. I'm done.
Done. Okay. Now here I have already derived 2 equations. So from this equation, v equals u plus at, v equals u plus at. In this equation, I am subjecting for simple t. Then t equals, we get v minus u divided by a. If you subject for t, you get v minus u divided by a. Okay.
Okay.
So in this equation, I'm substituting for t, okay, in this equation. So I write substitute for t in S equals u plus v divided by 2 into time. So then I get S equals u plus v divided by 2 times. Now t is equals to v minus u over a. Right? Simply in this equation for time, I'm substituting v minus u over a. Is that clear?
Yeah.
Okay. So then here 2a is in the denominator. I can multiply to the other side. It becomes 2as. And u plus v I can write as v plus u. Right? Because 2 plus 3 is equals to 3 plus 2. Right? Nothing wrong.
Yeah.
I agree?
Yes.
Okay. So then here v plus u times v minus u. Now what is this?
Average.
You may have studied in mathematics.
This
Now, for example, if you have a plus b times a minus b, this is equals to what?
a squared plus 2b plus c.
It's simply a squared minus b squared, no?
Okay.
The difference of two squares, right? A squared minus b squared is equals to a minus b into a plus b. Or x squared minus y squared is equals to x minus y into x plus y, right? The
Yeah.
factors of difference between two squares, right? Because you can do expand this and see, so you get that. Now suppose you have a plus b times a minus b. So first you have to multiply a with a, so you get a square, and then multiply with this plus and minus minus ab, and then you have to multiply this plus and plus plus ab, and then this and this plus and minus minus b into b is b squared. So minus ab and plus ab cancel, you get a squared minus b squared, right?
Okay.
Okay. So similarly, we can write here 2as equals to v squared minus u squared. Is that clear?
Yes.
So then we can subject for v squared. That means you have to take the u squared that side. So u squared plus 2as equals v squared. Therefore, v squared is equals to u squared plus 2as. V squared is equals to u squared plus 2as. This is the third equation. Okay, you can write down.
I finished.
Finish. Good.
Yeah.
Okay. And the next thing, v equals u plus at, right? So here I'm going to substitute for v. Substitute for v in s equals u plus v divided by 2 into time in this equation. So that I can write s equals to u plus, for the v I had to write u plus at, and the whole thing divided by 2 into time. So then I can write s equals u plus u is 2u plus 8t. This whole thing divided by 2, I separately divide by 2. Divide by 2, divide by 2. And all things should multiply by simple t. So then here 2 and 2 cancel. So we get s equals u plus half at into time. So then I can multiply with the time. So I get s equals to u into t is ut plus half into a into t squared. Half a t squared. So this is the fourth equation.
Okay. Okay, sir. Got it.
Done. Okay. Wait. Okay. So then we can write as a summary. You can write equations of motion. And then we'll write all four equations at once. One is v equals u plus at, and then v squared is equals to u squared plus 2as, and s equals u plus v divided by 2 into time, and finally s equals ut plus half at squared. Okay, so here write down.
Okay. Sir, finish one.
So V equals U plus 80, V squared equals to U squared plus 2AS is equals U plus V divided by 2 into time, and then finally we have is equals UP plus half AT squared. Okay, write down these two lines.
Okay, sir, I'm done.
And let's do some questions based on this. The rocket shown in figure 2.12 lifts off from rest with an acceleration of 20 meters per second square. Calculate its velocity after 50 seconds. Okay, so then you can first figure out what are the informations they have given, right? from rest. That means initial velocity is 0, u equals 0. Acceleration is given 20. And the calculated velocity after 50 seconds time is given. So we want to find what is v. So the equation which involving these four is actually v equals u plus at. Right? We can't use s equals ut plus half at square because s is not given. So we can use only this equation. So in substituting in this equation, then we can find v is 1000 meters per second squared. Easy, right?
Yeah.
Okay. So let's start the questions. Okay. I think you have already studied in your previous grade, right? Have you
Yes.
studied? Okay, good. Okay, then you can go with the question. Do the question number 9, 10, and 11. I finished the 9th question.
Uh, So I did part A and B of question 9, but part C,
Okay, and then let's first discuss the question number 9.
for part A, I got V is equal to 20 meters per second, and for part B, I got S is equal to 100 meters.
What's your answer for A?
20 meters per second,
20 meters per second. And for B?
100 meters.
100 meters. C, you didn't get the answer, no?
No, see, I'm confused on 100. Which velocities do I don't know, which velocities do I use?
Okay, so here then we'll do this question. Question number 9A. Calculate the velocity of the car after 10 seconds. So initial velocity u is given, acceleration is given, time is there. So we can use v equals u plus at to find its velocity. So therefore, velocity is v equals 0 plus acceleration is 2 into 10. So therefore, v equals 20 meters per second. That's correct. And B, Roman number B, sorry, not Roman number B, it's alphabetic letter B. Calculate the distance traveled by the car at the end of 10 seconds. So we can now use an equation involving with the displacement. So I use S equals ut plus half at squared. So S equals u is 0, 0 into any number is 0. So 0 into 10 actually, plus half into 2 into 10 squared. So 2 and 2 cancel. So 10 squared is 100. Is equals 100 meter. And C part, we want to find, calculate the time taken by the car to reach velocity 24 meters per second. So here you can simply use V equals U plus AT, right? Because now we know U and A, right? So V is 24 equals to U is 0 plus A is 10 into time. Therefore, time equals 24 divided by 10, which is 2.4 seconds. Is that clear? Is it clear? Maria, are you there?
Hello?
Hello? Yeah.
Okay. Sorry.
Is it clear?
Yes, hold on, let me write it.
Okay, sure. And you write and start the question number 10.
Okay.
You're done?
No. Sir,
Yes.
okay. For part A, I got 0.16 meters per second square.
For part A,
Yeah,
what is the answer?
0.16 meters per second square.
0.16 meter per second squared. Part B,
Part B, 8 meters per second.
8 meters.
And
Okay, and C,
part C, 800 meters.
800 meters. Let's check. A train accelerates steadily from 4 meters per second squared to 20 meters per second squared in 100 seconds. Okay. So calculate the acceleration of the train. So acceleration is simple now. You can use V equals U plus AT, or since we are finding the acceleration, you can straight away write V minus U divided by T. Right. So A equals V is 20 minus 4 divided by 100. So 16 divided by 100 is 0.16 meter per second squared, correct. And B, from its initial and final velocities. Calculate the average velocity of the train. So the average velocity is average velocity 4 plus 20
20.
divided by
Oh,
2. 24 divided by 2 is
wait,
12, no?
I made a mistake.
12 meters per second. And C,
Okay.
calculate the distance traveled by the train in this time of 100 seconds. So we can write S equals UT
Hold on, then I
plus,
made a mistake with that.
okay, yeah, sure.
It's 1,000 meters, right? Sir, I used the other equation. S is equal to U plus V over 2 into T.
Yeah, that one also can use. Okay, I'll do this question using both the equations. Okay, so here S equals U is initial velocity is 4 into 100 plus half into acceleration 0.16 into time is 100 square. So S equals 400 plus 0.16 divided by 2 is 0.08 into 100 squared is 10,000. So S equals 400 plus, here if you multiply 2 decimal place, so 2 zeros cancel, 800 will come. Therefore S equals 1000
200.
to 100 meters. So now let's do this using the other equation. S equals U plus V divided by 2 into time. So S equals, now average velocity, now this already we calculated, that is 12. So 12 into 100. So S equals 1200 meters. Since we know
Okay.
the average velocity during that time period, so it's easy to use the second equation, no? S equals U plus V divided by 2 into time. Understood?
Yes.
Okay. And you can try the question number 11.
10 meters per second. V is equal to 10.
10 meters per second. Okay. A car is moving at 8 meters per second. The driver makes it accelerate 1 meter for a distance of 80 meter. What is the final velocity? So here we can use v squared is equals to u squared plus 2as. So v squared equals u is moving at 8 meters per second squared plus 2 into accelerates 1 into distance is 18. So v squared is equals to 8 squared is 64 plus 2 into 18 is 36. So v squared is equals to 100. So v equals square root of 100, which is 10 meters per second. Okay. All clear, right?
Yeah.
Okay, so this deriving the equations of motion. So this part only we did, right? So first from the acceleration, v minus u over t. So therefore v equals u plus at. Okay. In equation number 2, considering the average velocity. When an object travels with its constant acceleration, its average velocity can be found using this u plus v divided by 2. So the displacement is equals to average velocity into time. We get c equals u plus v divided by 2 into time. And in the third equation, so here we can substitute for v u plus at. Then we can do some algebraic simplification. So you get s equals u t plus half at squared. So this equation 3, which we obtained as equation 4. And here for the t, we can use v minus u over a, so that we get the fourth equation as v squared is equals to u squared plus 2as. Okay. Yeah, so you can do this question number 12 and 13. I finished the 12th question.
Mm, mm. So the first question, I don't think I'm getting. Hello.
Sorry, your voice is not clear.
I don't think I'm getting. I don't think I'm getting it. Can you explain?
Sorry.
I don't think I'm getting the question. Can you explain?
Okay, so you didn't get the answer for the 12th question.
No.
Okay. Trials on the surface of a new road show that when a car skids to halt, its acceleration is -7. So minus means it's a deceleration. -7 meter per second squared. Estimate the skid to stop distance of a car traveling a speed of 30 meters per second. So then you can write this equation. V squared is equals to U squared plus 2AS. 2AS. So when they hit the brake, the final velocity when it comes to stop is 0 and traveling at a speed limit of 30. So 30 squared plus 2 into acceleration is -7 into
Yes,
the
just let me
distance
find.
we had to find. Okay, then this will be 30 squared is 900 plus and minus 14s. So minus 14s we can take to the other side, becomes plus 14s equals to 900. So s equals 900 divided by 4. So 900 divided by 4 is
14,
4
right?
into 2, 8.
So it's 900
Sorry,
divided by 14,
14.
right?
I want to get
It's
14.
64.29.
What's the value?
64.29.
64.29 meters.
Okay.
Okay.
Let me try the 13th also. I'll try it on the
Right?
one. I'll try the 13 and see.
Okay, yeah, sure. Sure. Okay.
Sir. Hello.
Yeah.
The answer is 25.495. So it's exactly 25 meters per second, right? If you round it up,
What is the answer?
25.495. So it's almost exactly 25, right?
Okay, let's check.
25.5.
Yeah. Okay, so at the scene of an accident on a country road, police find a skid mark stretching for 50 meters. Tests on the road surface show the skidding car decelerate 6.5 meters per second squared. Was the car that skidded exceeding the speed limit of 25? Okay, so there is a speed limit of 25. We have to show whether they are exceeding the speed limit or not. So we can use here v squared is equals to u squared plus 2as. So final velocity is 0, u squared, if we had to find 2 into acceleration is 6.5 minus 6.5 into distance is 50. So then we have 0 equals u squared minus 100 into 6.5 means 650. So u equals to square root of 650. Because you take 6 minus 650 to the other side, becomes plus 50, take the square root. So square root of 650 is 650 square 25.5. Yeah. So then u is 25.5 meters per second. So then we can state that 25.5 is greater than, writing the units, meters per second is greater than 25 meters per second. So you can state that the speed of the car, right here, is exceeding the speed limit. Speed of the car is exceeding the speed limit. That's why if in a road they have given a speed limit, we should not go drive above that speed. Okay, no?
Yeah. Could I just see the working?
Sorry?
Could I see the working?
I am sure.
So should I write for the last part of the question? It
Yeah,
was
here,
right?
so here we can say that 25.5 meters per second squared is greater than 25 meter. No? So then we
Yeah.
can say, yes, the car has exceeded the speed limit.
Okay. Thank you.
Okay. Okay. Uniform and by the way, do you want to do more questions on equation of motion or is it enough?
I think I'm fine with it.
Sorry?
I think I'm fine with it.
Okay. Uniform and non-uniform acceleration. Just find out some question and practice. If better, if you can get some past paper questions. It is
Yeah.
important to note that the equation of motion only apply to an object that is moving with constant acceleration. right? You can use equations of motion for objects which are moving at constant acceleration. If the acceleration a was changing, you wouldn't know what value to put in the equation. Constant acceleration is often referred as uniform acceleration. The velocity time graph shows non-uniform acceleration. It is not straight line, it is gradient is changing. So you can see in velocity time graph, we know the gradient is the acceleration, right? But here it has one gradient, here another gradient. So throughout the motion, the gradient is changing. So therefore, this is not a non-uniform acceleration. Is that clear?
Yeah.
Okay. Okay, so here the acceleration at any instant in the time is given by the gradient of the velocity time graph. The triangle in figure 2.18 shows how to find the acceleration at t equals 20 seconds. So if you want to find the acceleration at 20 seconds, what you have to draw is consider this 20 seconds. So it's here in this point of the curve. So you have to draw a tangent line. You have to draw a tangential line, and then you can consider this vertical distance and horizontal distance. Is that clear?
Yeah.
Okay. So draw a tangent line at the time of interest, mark a point on the graph. So here you have to mark a point on the graph. Draw a tangent line. You have to draw a tangent line. Mark a large right angle triangle and use it to find the gradient. So you have to draw a right angle triangle. That means this is vertical and this horizontal. Okay. And then therefore gradient you can take delta S over delta T, like this. So gradient is gradient equals to change in y-axis delta S is 10 meter and change in x-axis, the time axis is 20 seconds. Therefore gradient is 0.5. So here this 0.5, sorry, I think here this should be wrong. Wait. Yeah, so there is a mistake here. They are talking about velocity graph. So this one has to be delta V, which is equals to 10 meters per second. Is that clear?
Yeah.
So there is a mistake in the textbook, okay, because it is a velocity time graph. So this change in velocity only, so it has to be 10 meters per second. So therefore here 10 meters per second divided by 20 seconds. Now it will be acceleration 0.5 meter per second square. Is that clear?
Yes.
Okay. So now we know the gradient is acceleration, therefore the acceleration of the particle at 20 seconds. So therefore acceleration of the object at t equals 20 seconds is 0.5 meter per second squared. Right? So we have to give that particular time. At this instance, the acceleration is 0.5 meters per second squared. Because you can see every second the acceleration will change. It's not a constant, non-uniform acceleration. Okay. Okay, can you do this question number 14?
Yeah.
You have your textbook with you, right? Because
Yeah.
I can't get the. Yeah. Okay, now it's fine. You need more time?
Just a minute. For the first one, for part A, it's 220 meters per second and almost at 6 seconds.
What are the values of time and velocity? What is the time?
Time is 6 seconds and velocity is 220 meters per second.
Time
It's
6
almost
seconds. Velocity 220.
20. It's
Yeah.
almost at 6, not exactly. And for part B, um,
Okay.
we can draw tangent. Right?
Yeah. What you got?
I got points 340 and 12.
Sorry?
I got 1 point was 340, comma 12.
No, I'm asking the final value,
What do you mean the
acceleration.
final line? No, I'm confused on how to do it. I have the points. I
Okay, quickly, you had to draw a tangent, and then by considering the tangent, you had to find the gradient.
okay, hold on. The answer is 27.7. So it's
27.7.
like yeah, 7 8. 27.7.
What is the acceleration?
Mm,
Your voice wasn't clear.
So that's what I'm confused about. I'm fine with finding the gradient, so it should be 27.7.
27.7 meters per second square.
Yeah,
Okay, so those are your answers. And
that should be the
let's see.
acceleration.
Huh?
That should be the acceleration zone, right?
Yeah.
Okay.
Okay. So see the answers. Now the time and the velocity. Okay. Now if you check the time axis, so here 10 squares gives 5, right? So therefore 1 square is correspond to 0.5. So here this one is at the middle of this. The mid of 10 and 5 is 7.5. So therefore the time has to be 7.5 seconds.
Oh my god, then wait. It's wrong.
Here it's
Hold
in the
on.
middle now. Or else you can find the squares 1, 2, 3, 4, 5. So 5 into each square is 0.5, right? So 5 into 0.5 is 2.5. So 5 plus 2.5 is again 7.5.
Okay, wait, I made a mistake.
And in the velocity, you can see now it's 100 for 10 small squares. So each one square is 10. So therefore here 210, 220. So that's correct. So 220 meters per second is correct. 220 meters per second. Okay, and then we want to find the uh, acceleration. For that, we have to draw a tangent line. So I draw a tangent line for this point. and I'll extend this for till I get a good value. Okay, yeah. So this has to be tangential. Similarly, I can extend this side also till I could get a good um, okay. Mhm. So here side. Then we can mark the vertical and horizontal distance. So here 300 and this is 150. 300 minus 150 is 150 meters per second. And then here it is 1, 2, 3. Okay, so 10 plus 0.5 into 3 is 1.5, 11.5. Yeah, 11.5. And here the value is 4.8. No, 4.9. Is it correct? 4.9. Here it will be 2.5 and then 3, 3.5, 4, no? Yeah, 4. It is 4. So 11.5 minus 4 will be 7.5. 7.5 seconds. Therefore, acceleration is the gradient. A equals gradient is 150 divided by 7.5. So 7.5 into 1, 7.5 into 2. 2 into 10 is 20. 20 meter per second squared. So I'm not agree with your answer, because if your answer got something in like 19 to 22, then I can agree. Okay, you have got the reasonable close answer, right?
Yeah. I messed up the time with access.
Yeah, I think because of that only you have mistake and got the acceleration also wrong.
Yeah.
Okay. So methodologies, do you understand?
Yeah.
Okay. And you have to be very careful about the when marking these values. You have to consider each box how much it will value, magnitude, right? Okay. Shall I clear the screen?
Yeah. Hold on. Hold
Okay.
Sir, I'm done.
Done. Okay. Okay, so do this question. The velocity time graph represents the motion of a car along a straight road for a period of 30 seconds. Okay, so you can see the graph is drawn from time 0 to 30 seconds. Describe the motion of the car. Okay, so what is the motion of the car? What is the motion of the car?
It's decelerating.
Yeah, deceleration, but if you just say deceleration, it's not complete. You can see it's a straight line of constant gradient. You have to say constant deceleration, then it's much complete. Understood?
Yeah.
So velocity is decreasing, obvious, but it's decreasing with the constant rate, right? So therefore, describe the motion of the car. So we can say the car is constant decelerating. Constant deceleration. If you just write that also, I'm fully correct. Okay. So constant deceleration. B. From the graph, determine the car's initial and final velocities over the time of 30 seconds. Okay. Answer to this
Initial
question.
is
What is
initial is
the
20 and
initial velocity is
initial is
20,
20 and final is 8.
final velocity is 8. Okay. C. Determine the acceleration of the car. Okay, do that question.
Minus 0.4 meters per second.
Sorry.
Minus 0.4 meters per second square.
Minus 0.4 meters per second square. Okay. Minus 0.4 meters per second square. That's for the question acceleration. So acceleration is the gradient. A equals, so final velocity 8 minus 20 divided by time taken is 30.
30.
So 8 minus 20 is
30,
minus 2. Yeah, 30. Minus 12 over 40. Sorry, yeah, correct. Minus 0. 30 here. Minus 4
0.4.
meter. Yeah, correct. Okay. By calculating the area under the graph, determine the displacement of the car. Do that question.
Thirty-two point three meters.
90.
32.3 meters.
32.3 meters.
Yeah.
Okay, let's find. So the displacement is the area under the curve. So I can find this area. So it's a trapezium, right? So that for half into sum of the opposite sides,
You don't
8
have to
plus
take it as an triangle.
hmm?
The area under the graph, right? So it's only up to 30. So isn't it a
Yeah,
triangle?
yeah, this is the area under the graph, right? So it's a trapezium, right? So this is a
Then
trapezium, right?
wait. Then I didn't calculate all that.
Okay. So area under the curve, you have to find this entire area. So this is a
Okay.
trapezium. Or else what you can do is you can consider this rectangle area and find this triangle area. You can add those two. That way also can be done. But straight away we can find using the formula for the trapezium. That much easy.
It's 272.3. Hello.
What's the answer?
272.3.
272.3 meters. Is that your answer?
Yeah.
Okay, so here the area of the trapezium, half into sum of the opposite side, 8 plus 20 into altitude. Perpendicular height is 30 into 30. So then SC equals 1 over 2 into 8 plus 20 is 28 into 30. So therefore here we can simplify, divide by 2. 28 divided by 2 is 14. 14 into 30. So 14 into 3 is 42. Therefore 420, no?
Yeah.
420 meters.
Okay. Hold on. So can you do it in the other form? A triangle and rectangle separate.
Yeah, sure. So then when you consider composition of triangle and areas, rectangle, so is equals first this
Oh
area.
wait. I know what I did. I found the gradient, not the area. That's where it came wrong. Hold on.
You got the answer?
No, hold on. Got
You got same 420?
Yep.
Okay. So by considering these two area here, 8 into 30 plus, that's the area of this one, and this one is half into base is 30 into height is 20 minus 8, 12. So 8 into 30 is 240 plus here into 6, 13, 680. So 380, 420 again. And the last question, check your answer to part D by calculating the class displacement using this formula. So it's equals ut plus half at squared. You have to use this formula and find the displacement. So it's equals, what is the initial velocity? 20, right? So 20 into time is 30
30. Actually,
plus
that much
into acceleration, we found that is deceleration. So deceleration is minus 0.4. So minus 0.4 into 30 squared.
Hello.
Okay. So this equals to 2 into 3, 600. Minus,
Sir.
yes.
Okay. When we're taking the time at 20 meters per second, don't you have to take it as time 0? Or do you have to take it as 30?
Now u is 20 and time is 30 seconds. So it has been 30 seconds.
But
30.
not when it is at 20.
Sorry?
Not when it is at 20. Or do we not take that at all?
I think your words are not clear.
When the velocity is 20 meters per second,
Okay.
and the time isn't 30, right?
No,
It's
this
at 0.
u is initial velocity, no? And time is the time has spent.
Alright, okay.
Okay. So from this moment only you start to measure time 0 when it's 20. And then 20 into 30 is 600. So half into 0.4 is plus and minus minus 0.2 into 30 squared is 900. So it's equals 600 minus 0.2 into 900 is 180. So therefore it will be 420 meters. Okay, is that clear? Okay then. So with this we'll conclude the session, and today we have the other class at 1:30.
Yeah.
Okay then. Take care, study well, bye. See you.
Okay. Thank you, sir.
You can take a screenshot. I'm going to.
I wrote it down.
Okay, good.